When we envision a programmer or a developer, yeah, we think of a person behind a laptop screen writing lots of code, if-else statements, lots of code. And yeah, when a feature needs to be changed, and your manager comes in and he asks you to make that change, and you always need a developer, yeah, to make changes to that piece of code. That changed in 2012 with the upmarch of neural networks. This time, researchers or machine learning experts, they would create a model and they would feed it lots and lots of data, and then at some point, yeah, the model would start to recognize patterns. And like in this example, you see the difference between a cat and dog, which was fed with a bunch of labels. And the process is similar to how you teach language to a kid. Now, we're in a new time era. Now we're talking about generative AI and large language models. And before I go into that, when I was a kid, my favorite book was Matilda from Roald Dahl. I'm sure you must have read it. And what amazed me as a kid in this book was that by the age when Matilda in the book was 4 years old, she read the whole public library of books. She read every book that existed, and therefore she became a genius. And as a kid, I always thought, like, wow, imagine that you can read every book in the world. How smart would I be? Large language models kind of are like that. They're like huge models. They're models fed with huge amount of data, maybe petabytes of data, so that it's enormous. And then, yeah, they become this genius because they start to know everything. Well, I mean, if you know everything, yeah, then you also can explain the difference between a cat and a dog. My name is Boonstra. I'm a lead software engineer at Google. I work for the office of the CTO. We are a group working directly under the cloud CEO of Google Cloud. And yeah, we have an innovation team with a group of technical directors and a small group of software engineers. And we work on innovation experiments. So we try to build new things that don't exist yet, or with technology that are internally made by Googlers. And then we try it out and see if we can solve like big business problems with that. And yeah, generative AI and large language model technology, yeah, that's a big thing for us. Now, I'm also the author of the book, The Definitive Guide to Conversational AI at Google. I was the former developer advocate for conversational AI, and conversational AI and generative AI is kind of in the same space, so that's why I was there. And we recently finished like a big project for Wendy's, and Wendy's is the last fast food chain in the US, similar to McDonald's or Burger King. And yeah, we used large language model and generative AI technology to automate the drive-thru. And it's a super excited project that I'm going to explain more about. But before that, I'd just like to bring everybody up to speed with the idea of large language models and generative AI. Like, what is it really? And yeah, what can we do with it? So what is generative AI? I asked the Google chatbot Gemini this. And the chatbot says, like, well, generative AI, that's a type of AI that can create new content, including text, but also images of audio or even video and code. And it's trained on this massive, enormous data set with existing content. And based on that content, what it ever has seen, it can create new content. And it was similar to the data that it was trained on. And it used based on prompts. We'll talk about that in a minute. But before that, let me just start a little video. Louder. I don't hear audio, by the way, so... But you're not missing audio, it's just background music. But later in my presentation, I will need audio, so I hope that back there it will be done.
Yes, yes, yes.
Yeah, I hear something, but it needs to be louder. For later then. So there's a bit yeah, soft without music, but yeah, this it gives you an idea of what we can do with generative AI. Like this was very much focused on search. So what are large language models then? Generative AI, like large language models are in the bigger term, but then on text. So in the domain of text, and they're trained on a huge amount of data sets from various corpuses. So data can be from news sites, can be from public open source books, and then these models are trained on that, and then they can understand and generate new text. So what you can do with that is it can create new writing, it can translate text. It can generate summaries. You can also use it for writing code, like write code or translate code from one language to another language, or explain code or debug code for you. And it can also predict answers to questions, for example. Now, to a lot of people, this sounds like magic, but it is a prediction engine. And that's a whole different thing. So it's not factual, it's only statistics. So what it does, it is like you give it a prompt, and it predicts the next set of words. So when you fill in a prompt like input, it comes back with a list of possible words that could be the next word. And word for word, it will ask that, what's the next possible word? So for example, if I ask a large language model like, who is the president of the United States? It will tell me Biden. It's not because it knows it's Biden. No, it is because in the context of the United States, most people talk about Biden. It scraped that from its data. That's in their data set. So it will return Biden as the next word. It won't return my name because it never has seen data of that, or at least not yet. So it can also just generate the unexpected. That means like even if a large language model wasn't trained on doing translations, it has seen so much text in so many languages that, yeah, that it can also do translations really well. It can translate and knows the grammar. And that brings us to prompt engineering, because that is the most common way how you can, interact with a large language model. Most people think like, yeah, large language model, to interact with that, I open ChatGPT or I open the Google chatbot. But for us developers, and this is actually what a prompt engineer does, is like we take the model itself, so we talk to the API or to the model, and we use those configurations, to pass in and get an output. So the prompt, that is basically the input, and that can be anything, can be a question, could be something like, hey, please summarize this article for me. And then you send that to a pre-trained model, and that can be GPT or Llama or Gemini. And then it returns an output. And that again, that output is based on prediction of words, of like what it expects that the next word should be. So it generates new output that way. And I mean, it's very easy to write a prompt, of course, but I can tell you to write a good prompt, that takes a lot of time. And I can show you that later in the project that we did for Wendy, is that good prompt engineering, that's difficult. Because it matters the way how you ask a question, the way how you formulate your prompt, the word choice that you use, the examples that you specify, the format, even the amount of time that you click send to the model, it can generate a different outcome. It can generate a different article. So it takes a lot of time to do this well. To give you some history of the large language model, this started actually 7 years ago with the transformer. It's actually a research paper written by Google, and we wrote that that research paper to do language translations really well. Because 7 years ago, before large language model technology, when we would translate, like when we would use Google Translate or any other translation tool online, translation was done very literally, word by word. And now we all know that's a very bad way of translating text, because the word order matters. And it matters, like the context. You lose the context if you move around words. And there are languages like French, where you have like the language is gendered. These are all important things, what makes it hard to translate. And what the transformer now basically does, it is a deep learning model. So it's a GPU model with lots of data that we send in. But we we slap on every word like extra information, and this can be information about the surrounding words, and we call that the attention mechanism. And the idea is like once then because it's a deep learning model, once you feed it lots of data, then it starts to recognize that, it knows about the surrounding words, so it can do the prediction better of translating the words. And this transformer paper, that was actually the basis for the very first large language model ever, and that's BERT. And that was created in 2018, so that's a while ago already. Like even now we're talking about large language model technology, but the technology itself exists already for a while. Within Google, we then created Lambda, then we created AlphaFold and Palm, and now lately we have Gemini. I'm super excited about Gemini. I'm using this model a lot in my applications for building it, and I think what's really cool about the Gemini is that we have 1 million tokens context window. That's enormous. And what do I mean with the context window of 1 million? That means like when you write a prompt, I can use maybe 700,000 words to write that prompt. So if I would want to summarize an article, for example, I don't need to just put in an article. I could put a whole PDF document or a whole book maybe in the prompt. If I write a chatbot, I can just put all my previous conversations in the context, and therefore the prompt or the chatbot can become smarter. So 1 million tokens, that is huge. That's the most, that's the biggest context window that there is in a model. I think it's 7 times more than in GPT. So that's enormous. And the other thing what's really great about Gemini is that it's multimodal from the start. It's built as a multimodal model. That means that, I can write text prompts, I can ask questions, and the model answers me back. But I also could upload, for example, a picture. I could upload a picture of a map and ask the model, like, how can I go from point A to point B? And it understands, because it can read pictures. It can understand audio, it can understand video. So if I upload like a spoken podcast, it can answer me questions of the podcast, because it's multimodal. Now, Gemini comes in 3 different versions. Pro, that is what's also in the chatbot. That is also what you get in Google Cloud. But you can also opt for the Ultra version. That's like a bigger and more advanced model than Gemini Pro. You could run that in a data center, for example. And then we have Nano. That is more for lightweight, for if you want to run it on device, so on your phone, for example. And recently, we also did an update. We delivered Gamma. These are open models of Google. So you can get, as a developer, you can get these models from Hugging Face. And these are lightweight, but they're based on Gemini. So you can maybe train or fine-tune these models with your own data and implement it in your apps. Gemini is used in our chatbot, as I mentioned. Here you see an example where you see that it is multimodal. Like I ask it to generate a picture, and it generates it on the fly. But Gemini is also integrated in our workspace, so in Google Docs, in Gmail. I can ask in Gmail, like, hey, write this email for me, and it writes it for you. I could write a prompt in a doc and say, like, okay, can you write this document for me? And it does that. Slides even, that it comes up with the slides and the images for the slides. For developers, we have Gemini in Vertex, so you can take these models and you can fine-tune it to make it your own model and get it more knowledge from your own data. And then AI Studio as well, that's like outside of cloud, that you can just get the API key and talk to these models. We have Gemini in phones, in Android. Right now we have it in the Pixel 8 Pro, but we're planning to roll it out also on other Android devices. So where you see Gemini in this case is in autocomplete. And then we also have the search experience. So in search, eventually we will get that, that you can ask questions in our search bar, and then it returns, generates answers for you. But then it's integrated, and that's also for our chatbot. Like the Gemini is integrated together with the Google technology, so we know we can get facts. We can get it through our Google knowledge base, and we get it right away. Like so, even if something happens yesterday, we can show that. Search engine, the search experience, that's currently only available in the US, but we're planning to obviously to roll that out everywhere. Now, to give you some use cases, and I would like to go quick through this because I do want to spend a lot of time on, on the Wendy's case. So I'll just go quickly through these. But examples of where you can use generative AI for is in obviously content generation, generating an article for your website, customer care, like building a chatbot, or maybe in a telephony center where a robot picks up the phone. Understanding data, like explain, like, hey, what's in my database? How do I write this query? SEO, like help me with finding the right keywords for my website, or doing the planning and strategic behind it. As a developer, I use it myself, the chatbot, to write code. My life as a developer changed, I would say. In the past, I would just browse API documentation all the time. Now I don't do that anymore. I just ask the chatbot it, and I get the right answers. And sometimes it's wrong, but then I just change my prompt in the way I ask it, and then I'll get the right answer back. It's still faster than browsing enormous API docs. Yeah. And translation, of course, like language translation. But as I mentioned, I would like to talk a little bit more about the use case that I've been working on with my team, and that was for Wendy's, like a last fast food chain. And we used it to automate the drive-thru. So you can imagine, like in a Wendy's restaurant, like there are like people that are working there. They wear headsets, and when the cars drive in, like they're making burgers while they're talking to their customers, and that is very complex. It's also the case, like this is a $1 billion business case that every fast food chain is interested in, because like if the line is too long at the drive-thru, yeah, what will you do? You drive further and you drive to the McDonald's next door. So like this is something that these businesses want to solve. And you can use generative AI and large language model technology for this. Like the obvious thing is to think like, oh, we use it for content generation, but I'll show you how we use it to innovate. Typically, when you build chatbots, a chatbot is more like a tree with branches, right? And every branch in the tree leads to a different outcome in a chatbot. But if we talk about food ordering is way more complex. But there is no whole tree with branches. There is actually only one branch. It's like put this item on my cart. But to put that item on the cart, that is what makes it complex. Because as you see here in this example, I'm talking the entities. That's what matters here. Like I can talk about, I want to order 2 hamburgers. These are combos with fries, one with a Diet Coke and the other one with a Fanta. Then I want 1 Diet Coke with extra pickles on the burger, or actually I want a cheeseburger instead. This is already for a human difficult to understand, and for a machine this is difficult as well. Because we're talking here about all kinds of entities. How does it know that the hamburger is not the side, but the main menu? How does it know that pickles is the modifier for the burger and not for the fries? How do we know that is the modifier before or after? How many burgers do we need to do that? Oh, and at the end we're changing the order. It's not a burger, but it's a cheeseburger. It's way more complex than that, I would say. That is what we figured with our team, because at Wendy's, for example, they work with a morning menu, like a breakfast menu, and then they have an evening menu or a day menu. They have seasonal products, they have like promotions and deals. There are lots of products that you can modify, and then you can end up with 101 billion combinations of the same burger. So I can say I want a cheeseburger and with lettuce, but not with pickles. I want to have double burger. I want to have extra sauce. Like that's how you make these combinations. And also, like the amount of times that people go at Wendy's, they order a Big Mac. But they don't serve Big Macs at the Wendy's. No, they have the Wendy's equivalent, which is the Baconator or the Dave's Double. You know, so like people order Happy Meals, people order like milkshakes. They don't have milkshakes at Wendy's. They have Frosties. And their kids' meal is called kids' meal. You know, like this is what makes it hard to understand and order. People are also used to make an order with a human and not with a robot. And the speed of the order matters. Like we need to do this all within 30 seconds, because otherwise the line increases. People use slang in their words. It's complicated. And then on top of that, yeah, we also have to deal with the hardware, like we hear engine, we hear the motor of the trucks, we hear kids in the back seat yelling, you know, we have people that sit next to you that say like, no, actually, I want another cheeseburger. You know, like it's complicated for the machine for the microphone to pick up the right order and to understand what actually it meant. I'll show you a demo, and in this demo, this was the demo that we did to the board at Wendy's, where we used Palm, our text Bison model. So this is already like a while ago, before we had Gemini, on how we can do this right with like building this robot to automate the drive-thru. And the example that you here see is web-based, but we rolled it out into the restaurants through their own hardware, but with a similar board. So let's hope the audio works.
Dave's double with mayonnaise and pickles.
Got it. Can I get you anything else?
Can I get a small, medium, and large fry with that?
Got it. Can I get you anything else?
Can you make that a Dave's triple instead of a Dave's double, but keep the same toppings?
Got it.
Can I have a Dave's single, a Dave's double, a Dave's triple, a spicy chicken sandwich, a Baconator, and a Son of Baconator, all with tomato?
Got it. Can I get you anything else?
Can you add lettuce to the chicken sandwich?
Got it. Can I get you anything else?
Can you remove all the Dave's burgers?
Got it. Can I get you anything else?
Okay, can I get a Cobb salad, a Baconator fry, garlic fry, a pub fry, a chili cheese fry, a sugar cookie, and a vanilla frosty?
Got it. Can I get you anything else?
Remove all the fries.
Got it. Welcome to Wendy's.
Yeah, so you can see we can do very speedy ordering, and we can just say the weirdest things, and it will pick it up, and it will understand like the similarities, the differences, the slang. Now, the way how we built it is like we first took the Wendy's menu and we fine-tuned our own model with that. We once a car drives into the drive-thru, we use the Wendy's microphone, and we take the spoken audio and we transcribe it to written text. And that is the written text. We would send that to our own large language model, which we call the semantic parser. And what it did is it took that order and it parsed it to a JSON piece of code. Because JSON, that is of course the way how the point of sale system in the kitchen works. But it also, we figured out, like when you do parsing or when you try to understand prompts, works the best when you work with JSON, because then the large language model tries to stick to the JSON code and tries to keep the right variable names, etc. So that was the main key. Try to parse it to code first. Then we built with another large language model an embedding matcher. So that is for every time when a person orders a Big Mac, then we match it to the Baconator. Or when a Happy Meal was ordered, then we know no, it's a kid's meal. It kind of also works like a guardrails for us. So if people would go totally off track and say something totally random to the model, the matcher would still bring the conversation back to the order. It's like, well, I don't understand what you're trying to order. What would you like me to add? You know, so we would always find the right products. If you order something that's not available, the matcher would know and would fine-tune your question, would ask your question with you to make sure that the right items could be added to the cart. We used large language model technology to do Q&As. So you could ask, for example, is there gluten in this burger? And then finally, once we have we match the order, then we would show that on the screen, and then we would also send it back to the synthesizer in speech, so that we have the robot in a human voice that could talk back to the customer. And this was a big success. We rolled it out first in Ohio, and it became viral with it. It was all on the TV in the US and everywhere, on the news they were talking about this, because this is such a big use case that every restaurant is interested in. Plus, it's also a big example of how you can use large language model technology to innovate. And with that, I'd like to close this presentation, like large language models, those are like the Matilda, like that read the whole library of books and therefore become that genius. And they can help you with generate text or languages or write different kind of creative content. It can write code for you in an informative way, but it's also still under development. But it can revolutionize the way how we interact with computers. So thank you.